Let's have a look at the last two examples on factorization by grouping, and this will definitely bring us to the end of our discussion on factorization. What you've got here, you've got x squared minus 6xy plus 9y squared minus 8. If there's one thing that should make it obvious that you cannot even try waste your time and look at the grouping then the grouping there, is the fact that you've got a squared, a variable that only appears once in this. So this should kind of direct your thinking as to the approach that is to be used on this problem. So what you want to do actually here is to consider then factorizing the trinomial and see what it comes to now. Of course, if you are not aware of this, whenever you have a square binomial, let's check this. If I've got a square binomial x minus y all squared, in other words, then this simplifies into x squared minus 2xy plus y squared. And what really happens in the middle term is that I have taken this product here, I've multiplied it, but just after multiplying, I also multiply by 2. In other words, I say x times y, then I multiply by 2. This will be the same thinking that goes behind the product x minus 2y all squared. This becomes x squared, right? Then minus 2xy times 2 will be 4xy, then I have plus 4y squared. Now, if you think about this, it will be the same thing for x minus 3y all squared, which is actually what we have there. Let us see if that's the case. This becomes x squared minus 3xy times 2 becomes a negative 6xy plus a 9y squared. And so if you guys have done a lot of this in your previous grades, that is grade 9 in particular, especially, you will then realize right away that, oh, actually I've got a square binomial here. So you can see right away that this thing actually factorizes as follows. It becomes x minus 3y, and it has to be all squared minus a squared. In a case where you did not see this, you will of course want to factorize this. And in our case, we use the portion law method. Let's see if it will factorize. Of course, I hope you can see that this will just simply become the difference of two squares. So you'll actually have x minus 3y minus a into x minus 3y plus a. That's it. But now let's see how would you have factorized this using the portion law method. Our method that I said is very consistent and actually works always. So if I have this, then what I would have done is to note, I start by saying my sum should give me 6y. Now, the reason for this is because I am treating y, the variable y, as a constant. Okay, that's the important thing. This is a quadratic expressed in terms of more than one variable. So if you think of this, a here, I've got ax squared. Now, in this case, my b is actually 6y. Then I've got my x term there. And this entire 9y squared is my constant. So I'll do that and I say, well, the product here should be then 9y squared. Then I just follow that same process that says, I know I've got to halve this, the sum, so that becomes 3y, and I know a certain number u and another certain number u. When I multiply them together, they are going to give me a 9y squared. And then this is the difference of two squares as always, so I'm going to have 9y squared minus u squared is equal to 0. Not 0, my bad, should be 9y squared. So this is 9y squared. The interesting thing here is that 9y actually takes care of 9y. So actually at the end of the day, your u is a 0, which is very nice because then it says your factors are actually, now if you think about this, I'm going to substitute a 0 here. Your factors are actually 3y and 3y. What does that mean? If I have x1 equals to 3y and x2 equals to 3y, then this means x minus 3y is a factor, but this also happens on the other hand here. So x minus 3y is also a factor. But this tells me that this thing can be factorized as x minus 3y into x minus 3y, which becomes x minus 3y all squared. And this is exactly what I had there. So you can see, actually, the case where u equals to 0, you are going to have a square binomial. Okay, so that is another nice thing about this thing. In grade 11, of course, you will then discuss this under the topic that says nature of roots of quadratic equations. Okay, so just thought I should bring that out to your attention so that you can see what is going on. So yes, there you are. You've got your final solution and your full marks. I'll just do the next example in the other video. Cheers.